Hello, this is Dr. Kraus with a quick video on how to calibrate and use your line sensor array. First thing I want to say is when you're calibrating, it's important, the mounting of your line sensor is going to matter, and the distance from the surface to the bottom of the sensor is going to matter a little bit. I think for now we're recommending maybe something in the neighborhood of 1/2 inch. And when you calibrate, it should be at the same height as when you're actually going to use it. So if it's attached to your robot, that's easy. Just leave it attached and move the whole robot across. But pay attention to this height if you're just playing with it for the first time and it's not yet attached. The next thing to be aware of is that when you're calibrating, you're sliding the sensor back and forth so that the line sensor array back and forth so that each of the sensors underneath spends some time reflecting off of white and some time reflecting off of black. The calibration procedure is then going to compare the minimum and maximum measurements to figure out that under these lighting conditions, this is what a black reading looks like and this is what a white reading looks like. So just keep doing that the whole time the software tells you that it's calibrating until you see the calibration results. Okay, next let's talk about the software, where to get it, and the modifications I made to it. If you follow the link that's in the slides that takes you to qtrrcexample.ino on the Pololu GitHub site, this is the code. Click raw and copy and paste, or just click the download buttons, probably slightly easier. The code as it comes from their GitHub page just starts calibrating immediately when your Arduino is powered on, and it doesn't tell you until the calibration's done. So I made some changes to make it more intuitive in my opinion. So first of all, you have to change the sensor count because the current sensors, at least in Winter 24, do not have 8 sensors, they have 5. So I changed that to 5 here. You have to do that. I moved this serial.begin up to the beginning of the setup so that I could print to myself a welcome message to just kind of let me know, when the software is starting. Here I changed both the number of pins and the pin numbers themselves. So when you open the example code, I think this says 3, 4, 5 up to like 10 or something because there's 8 of them. Now I only have 5, and my sensor array happens to be connected to pins A5 through A1, but they're backwards compared to the pin numbers that are on the board, so I've got them decreasing. And then my LED on pin is connected to A0, so I changed that as well. And then I added this extra delay and this calibrating message to tell me when it's going to start going into the calibration routine. And then I also had it print every step through the calibration so I know that it's going and I know when it's done. It's going to print the numbers 0 through 399. And then it's going to print the calibration results. And we'll look at that in just a second. And then it goes in and it does its thing where every time through the loop, it's going to read the position as an integer between 0 and 5,000, 4,000, I think, for us. But it's also going to, so sensor values is an array of sensor count number of integers, and so that's the value for each sensor, a value between 0 and 1,000, and then the position number is the weighted average. And so it prints out each of those sensor values followed by the position value. Okay, with that, let me do a demo of what using this actually looks like. So I think I'm ready to come in here and upload the code. And it's doing its thing, and it's going to tell me that it's done uploading, and I think everything's happy. So open the serial monitor. That causes the Arduino to turn back on. I see my demo welcome message. And then let me also show you my camera. So I'm moving this back and forth while the calibration counter is running. And then I got to be ready to stop the auto scrolling in just a second. Right there, pause. So what I want you to see is that a successful calibration, it's going to print one row that is the minimum number, and then one row that is right. So in the code, first it prints the minimum calibration time, and then it prints the maximum calibration time. And so what you'd like to see is one row of fairly small numbers, and those are actually kind of mediocre. I'd like them to be even a little smaller. And then one row of really large numbers, and those are pretty good there. Then, if I turn the auto scrolling back on and also show you my document camera, what I want you to see is that I slide this thing across, and in here, this number that's a big number is going to keep moving back and forth as the line is underneath a different part of the sensor. And so if you don't see that large number moving back and forth across the columns as you go, and these first 0, 1, 2, 3, 4 columns are the sensor values, and then this last column is the position value. So if I'm way off over here, apparently the way I have this wired up, that's 4,000, and then as I slide back across, it eventually goes to 0. So it's returning an integer value that is a measurement of where the line is underneath the sensor, with 2,000 being roughly the center of the sensor. So if you're trying to line follow, you're trying to drive that value to 2,000. And again, just make sure you're seeing that this larger number moves back and forth as you move the sensor across. And if that's not happening, something went wrong. And if your calibration values don't include one row of really small numbers and one row of really large numbers, like this, then something went wrong with your calibration. If they're all perfectly 2500, I think that's a sign that you're not powering the sensor array. But yeah, that's really all there is to it. Thanks.